Good morning. This is your stat sensei, Mr. Spensei, and this is a warm up on education pays. A sociologist is investigating the relationship between educational level and income. The hypothesis is that individuals with higher education levels, such as a bachelor's degree, earn more than those with just a high school diploma. So let's go ahead and highlight that because that's going to be our hypothesis. Sounds like our alternative there. So it looks like to me our HA is going to be higher education, more income than just a high school diploma. And I put HD for high school diploma. The sample, it should say of 100 randomly selected individuals with a bachelor's degree. All right, so we have an N1, that's for our bachelor's degree, and 100 randomly selected whose highest education level is a high school diploma. So this is our high school diploma. So that'd be our N2. The mean income for the bachelor's degree is 57,000. So X bar for the bachelor is 57,000 with a standard deviation of 8. And that comes from the sample, so this lets me know it's a two sample T. While the mean income for the high school diplomas is 35,000, so that's X bar over here is 35,000 with a standard deviation of 6,500. More than 5 million adults have a bachelor's degree. Oh, this is our population. So 5 million. That's our pop. And more than 10 million adults, the highest they have is a high school diploma. Calculate a 95% confidence interval to estimate the difference in mean income between individuals with a bachelor's degree and those with a high school diploma. So 95% confidence interval, what we want. And our warm up is to check our conditions. Well, our first condition is always random sample. We need two independent random samples. We have to say they're independent. We need N to be less than 10%, and we need both samples to be normal by central limit, normal in some form or fashion. So random sample of 100 for the bachelor's, and that was given. So that's good. We have a separate random sample of those who graduated with a high school diploma, and that was given. So that was good. So we have two independent random samples. And as I've said before, I just like to say we have two independent random samples. One of 100 for the bachelor's was given, and one for the high school diploma is also given. Our sample size was 100. 100 times 10 is 1,000. That's less than 5 million. And 100 times 100 is 1,000. And that was 10 million because both samples for the bachelor's and for those with a high school diploma was 100, and the population was 5 million for those with bachelor's degree, 10 million for high school diploma. So N is less than 10% of the population for both samples. Barely gave myself enough room. Should have started over at the edge. All right. Now, our sample sizes are 100, which happens to be greater than 30. And once we hit the 30 threshold, it's normal by central limit theorem. And that's true for both of them. So we're good to go. All the conditions are met. Once again, random sample, two independent random samples for both. Sample size needs to be less than 10%. It was for both. And then they were both greater than 30. So they're normal by central limit theorem. All righty. I appreciate you watching, and I look forward to seeing you on the next one. Thank you.